So like Jason said, I'm Thor Andreassen, or Thor A to some of the people in this group. Yes, you have the pleasure that there are two gods of thunder in this room. And yes, on behalf of 100% of us with the name, the H is silent. But yeah, it's my pleasure to talk to you guys today about the data tools and models you want might already exist, and here's why you might not have found it yet. We're off to a good start. Okay, so a little bit about myself as to why I think I'm somewhat qualified to give this. During my PhD and since in my postdoc, since joining Mayo Clinic, I've had the pleasure of publishing 6 works that as first author, all of which have provided either some data, some tool, some model publicly available, right? I was involved with cadaveric work, human subject work, modeling, device creation, medical device testing, like materials testing. So I've sort of, the joke was I like knew nothing but a little bit of everything, right? I was kind of the jack of all trades within the lab, right? And at the same time, I've been fortunate that a lot of my research has been heavily based on tools that other people have made resources. And so, like Steve had with FE-Bio, and there's the reframe, so on. Those are some tools I think that are, pretty well known, or at least known to a larger group of people. But as an example, these are ones from my own research that I can tell you 100% guarantee I would not have completed my PhD without every single one of these. And yet, show of hands, how many people recognize at least one of these? Okay. How many recognize all of them? Right? So for the people online, it went from like 20 people recognize one, 3 people recognize all. And I'd argue that's kind of the point, right? Yeah. And my speech there, right? Like there's all these resources that exist that might be crucial to my work, and yet someone else doesn't know about them. And by the same logic, I'm sure there's a lot of resources you in the audience are aware of that I certainly have never seen before and would be truly, transformative on my work, right? And so why is it that some of us aren't aware of all these tools that people are creating, these resources, right? Well, it's a complicated question. Different people would disagree. But at least in my experience, I think it really comes down to one major component, right? Which is that the people who are using these resources and the ones creating them, oftentimes they're not the same person, right? And even more so, they don't necessarily wear the same hats, right? So like if you're talking medical imaging data, the people creating that are often, let's say, radiologists, medical physicists, hardcore like orthopedic people, right? On the flip side, us using it, right? We might be modelers, right? I come from the current department I'm in is PM&R, right? So the physicians want to use this, physical therapists want to use this, right? But they inherently have different things about what it is they care about or what they don't care about, right? And oftentimes when they're asked to communicate with one another, that signal that they're trying to convey has a lot of noise in it, right? The message sort of gets lost in the weed between, I need this from the person creating the tool, and the person creating the tool is, I can't give you this, but I could give you this, right? It tends to get lost. So how do we fix it? So my current boss at Mayo Clinic, Dr. Kristen Zhao, is a big fan of wait till the end of the presentation to tell people what they need to hear, because they're probably going to fall asleep by then. So step 1, well, that noise that exists between these two groups, it needs to go away, right? As part of this ecosystem, my biggest recommendation would be make it easier for the people who are developing these tools, the people who are using them, to actively tell one another what it is they can provide, what they can't provide, or what they want and what they don't want, right? But at the same time, I would argue we should go one step further than that, right? Not just open that channel, but actually truly understand what it is these people want, right? The people who create data have their own, the 6 W's, if you will, the who, what, when, where, why, and how, right? So who is it that's creating this data? Are they radiologists? Are they biomechanists? Who's using it? Are they physical therapists? Are they physicians? Are they modelers, right? They're each going to have their own category of what it is they truly care about based on their own experience and, where they're coming from, right? And I think it's important to make it more obvious to people, like, Who are you? Why are you interested in this? Where does this come from? Why did you, when you created your data set, let's say, why did you focus on this? What question were you answering, right? And then if you're trying to use it, why did you download this data set instead of this one? Why is it that you're using walking speed as the ultimate benchmark, right? It's easier if we sort of understand where the other person's coming from. And in my experience, the best way to do that is to start to blend your roles, right? Maybe instead of wearing these separate hats, it's easier if we start to merge our hats, right? And, you know, the very engineering artist in me, you know, big, deep thought, right? I'm not saying that you change roles entirely, right? Still leave some roots to what original hat you brought, but maybe get experience with the other side, right? So if you're always using data, there's this classic question of someone who's providing it says, what data should I collect? And the answer is always all of it, right? You know, one of the ones that came from our lab that I particularly liked with my former PI, Kevin Shelburne, was the people who aren't responsible for the data are always the first to complain about it, right? If you weren't there during the data collection, you're like, well, why didn't you get this? How come you can't put the person through the CT scan for an additional 2 hours to get this, right? But at the same time, the creators, the people using it are like, well, you're smart, you should be able to figure this out, right? And they're like, that'd be great, but it doesn't exist, or I don't know what to tell you, right? So like one of the ones I always hear is, you know, the clinicians I talk to, they sort of want the line in the sand of when do I cut, when do I not cut? And the engineers are like, well, that depends on how much risk you're willing to take, right? You know, I have a dad who's in aerospace, and the way they do it is the deciding thing is based on the probability. If there's a 1 in a million chance the rocket fails, probably okay. There's a 1 in 1,000 chance the rocket fails, the conversation's a little bit different, right? So I think if we start to experience what it's like to be from the other side, right? If you're only ever using data, try sharing it once, share some tool, get experience with that side of it. And by the same logic, if you're only ever creating it, you don't always know what the other side actually needs, right? The clinicians often tell me, they're like, you engineers, you're creating solutions to problems I don't have, right? They're sort of like, we're focusing on efforts on our things that they think are great, but they're not actively going to see clinical practice, right? So as an example of this, I thought I'd share a little bit of one project I've had where I've started on the side of using the data, then was on the side of trying to develop it, and since then have been using it again, right? So show of hands, how many people know what the visible human is? For the people online, it's almost everyone in the room. So visible human, for those of you who don't know, up until the Human Genome Project, these were the 2 most studied human beings of all time. So in the 90s, this group from Colorado basically decided they want to create an imaging database of these 2 people. So they created super hyper photorealistic images of these 2 people. And in the 90s, it was the basis of a lot of like automated segmentation work with the ultimate goal of basically creating these atlases. And these atlases, a lot of them, whether you know it or not, they were the basis of sort of medical training for medical professionals for the last 20 years. If it wasn't a textbook drawing of that muscle, chances are it was from this image, right? But then the people who were using it were sort of like, that data is great, but this could be helpful for me as a modeler, but I don't have access to that, right? A lot of these got put behind paywalls, right? They would show you where these structures were, but you didn't have access to the data that physically told you where it was, right? What it looks like. So then in, let's say, around 2015, and this is by no means exhaustive, 2 groups that were sort of from the electrophysiology, electromagnetic background, they said, well, we want to be able to tell how is it that electromagnetic interference, X-rays, gamma rays, whatever, might be affecting people, because they had a background in trying to identify like how these radiation from, let's say, CT scans or something might be causing people some risk of, you know, cancer or something. So these 2 groups sort of simultaneously, but released at different times, created these data sets that, again, they're the same people. This is still the visible human male on the left. And this is the visible human female on the right. And they basically segmented these structures and provided publicly available data of this is what is in this picture. This is where this muscle is. This is what's bone, so on. But their background was in just trying to model, is it muscle or is it fat or is it bone or this? Because they just wanted to see You pass x-rays through someone, what parts are going to light up, if you will, right? So then my group, for instance, we saw this and we were like, oh yeah, we would love to use the quad muscles on the one on the right, for instance. But if you're used to doing modeling, you look at that and there's two things that come out obvious right out of the gate. One, that mesh is horrible, right? These element sizes are almost probably 30 millimeters, so effectively useless. And two, they kind of grouped everything together, right? Because what they were planning on using it for and what they thought people would want was, is this muscle, is this bone, right? But our group was like, we're trying to model quad mechanisms so that we can have someone kick. There's 4 quads, it's in the name, right? So we can't just have them as one. So we felt like, okay, well, what if our contribution is we're going to try and provide that data, right? So we had been downloading these and finding that they didn't meet our needs as on the user side. So like we're like, all right, let's go to the other side. Let's actually try and create this resource. So over the course of 3 years, and I think 10 people touched this in total, we segmented out pixel by pixel all the muscle, fat, cartilage, ligaments, soft tissue, not neuro, for the lower extremity down, both legs, male and female. And additionally, given our modeling background, we wanted it to be usable. The thing that annoyed us the most was we would download some data set or we'd find someone had provided the visible human with this. And we download it and then we look at it and we're like, that mesh is terrible. I'm gonna have to spend like weeks fixing all this, at which point I should just start from scratch anyways, right? It would take less time. So we wanted something that said, from our perspective, let's give people what we think they want, which is you download it, you put it in the model software and you hit run and there are no convergence issues, right? So that's what we did. So that even required us developing a truly novel algorithm, right? One of the things we had was anyone who's done explicit modeling knows if you have overlapping regions between adjacent geometries, even if it's on the micro scale, your models tend to blow up. And usually the way people fix that is they just manually go in and maybe adjust some nodes or something. And that's fine if you've got 4 muscles in the knee and you're modeling the quads. It's not that fine if you've got 260 adjacent geometries and there are literally 45 million overclosures, right? So we had to develop this tool that could actually remove them. So as both part of this exact same work, we said, here is this data that we're providing. Here are these models, and here's this tool we came up with to make these models better for you so that they're easier to use. And then came the question of, well, what would people want from this, right? Where do they want this data? And it's kind of like everything, right? Both, right? Should we provide processed geometry or unprocessed? Well, some people might want one, and some people might want another. Or do we provide just the segmented geometries, or do we provide the initial segmentation? Well, how about both, right? Some people might want different ones. And then at the same time, do we provide it as TIFF stacks, which is what a lot of engineers might be used to seeing? Or do we provide them as DICOMs, which is more what clinicians might be used to see? And again, it came back to both, because then we think everyone might be able to use it. And so we basically did our best to provide everything we could possibly think of. So there are literally 20, I think it's 15 different things you could technically download that are this workflow at a different stage with a different file type for a different purpose. And we thought that would cover everything. And since we did this, we published this in, I think, the beginning part of 2023. It's already been downloaded over 5,000 times. It's been used in, depending on who you ask, 20 different publications. I get roughly an email about this every couple weeks, I think. And some of the things people have been using it for are ones I sort of saw coming, right? Like one of the geometries we published was the soleus. Someone basically published a paper, how does that volume change as someone walk? But we've also gotten some that I never saw coming, right? So this one right here is one from Caltech like 2 weeks ago. Visual surface wave elastography, revealing subsurface physical properties via visible surface waves. And this group is actively trying to go for, they have similar work where they've got preliminary patents in case, right? So they're actively like going for this, right? They're full speed ahead. And I think part of why it's gotten traction is we did our best to think, who is it that might use this? And what would they potentially want? And not just focusing on knee, but we said, broader than that, and not just focusing on modelers. We said broader than that, right? I gave a talk at Mayo a while back, and one of the physical therapists in there told me they found my data set and they used it to sort of learn the anatomy because they can manipulate these structures. And it's free, as opposed to the anatomy like website they were used to using had a massive paywall, right? But at the same time, there were some, let's say, less than positive outcomes, right? So over here on the left, you can see this is where the data is currently stored. It's on the University of Denver's Digital Commons. So it's sort of like a university-specific data repository. And over the last year, I compiled some of the more interesting questions I've got, which is like this first one. You indicate the data discussed therein is available for download. That page appears to not have any links, right? So as we scroll through here, it goes kind of fast. But what they're referring to is they don't actually know where to click to download it, right? And it never occurred to me that someone would have an issue. But it turns out the way we have it set up, you have to know to click this. Because we tried to separate it out so that if you only wanted the mail, you could get that. And once you're at the mail, you can only download the segmentation if you want, or you can only download STLs because the total file size is like 370 gigs. But it turns out by trying to make it easier for people, we simultaneously made it harder for some to find it, right? At the same time, one of the things we did not do was we sort of made a general blob, if you will, that was kind of the fat and skin together, because it never occurred to us. We were like, well, what are the odds someone's going to care about just the skin and nothing else? Well, it took less than 2 weeks before I got this email that said, I'm interested in undertaking some electrophysiology modeling studies. I was wondering if you had any smooth STL files for the outer surface of the leg. And then they went on to say, specifically the skin. And I had to tell them, well, no, because I didn't know anyone would want that, right? And over the course of those 3 years, it never occurred to me that someone would have wanted that. And had I known, it probably wouldn't have taken that much time for us to give that to someone. But now 2 years out, right, it's sort of done. It'd be a lot of work for us to go back and add that piece in there, right? And then in the same way, this person, despite all my work from the NeHub stuff, a lot of the people in this room are tired of me saying it. Like, I'm going to die on the hill about coordinate systems. I thought I would be the one to know how to do it. And yet it took less than a month and I got an email of like, I don't know how to recreate it, right? So it just goes to show, despite my best intentions having been on that side, you know, I was able to pre-see some of what it's useful for, but at the same time, I missed some things, right? And then the biggest one is, despite it saying several times it's the lower extremity, it took 1 day before I got this. And I'm not going to name names, but this is from someone I know. And I was like, bruh. I was like, I mean, so I told them, I was like, no, that's your job. I spent my 3 years. I put in my time, right? So kind of what's my point of this talk, right? Well, it's that having been on both sides of this and constantly going back and forth, what I've sort of figured out is that we need to make it easier for the people who are developing these tools to talk to the people who are using them. And that one of the things that I learned as a mistake was I asked them initially and then didn't follow up. And 3 years went by and things changed, right? So like a classic example, right? In the AI world, the big thing to share data and models now is called Hugging Face. It didn't exist like 4 years ago, right? So they have completely switched gears. So if you published your data on what they were used to use, can't think of what it is off the top of my head, you would be thrown to the wayside because they have moved on, right? Or in a similar vein, right? You know, STLs used to be the standard format for sharing geometries. Well, most people have moved on from that, right? So that was what we shared it because that's what we thought was helpful to people. But I've gotten a lot of requests over the years of people saying, well, I actually like OBJs now, or I want this, right? And had I known that at the time, things might have been easier, right? But so I think what's important is for us to highlight, you know, from both the creator and the user standpoint, who are these people? What do they want? Where are they coming from? When do they want it? Why do they want it that way? How do they want it? And that'll make it a little bit easier for us to move forward, right? And I think a big part of this ecosystem, in my opinion, should be around making it easier for this to happen. and that this shouldn't just be a one-time thing. This is a continuous process. But with that, I'd like to thank you all for listening. Happy to take any questions, I think.